Hi class! The goal of this video is to look at a quick review of the formulas that we used in this course and explain some examples of how you might use them. So one of the formulas we looked at was the quadratic formula, and this of course is useful whenever you need to solve a quadratic equation. So if I have something with, difficult numbers that isn't really easily factored, so something like that, right? In this equation, I've got an a value of 1, a b value of 3.2, and a c value of 7.3. I can plug those numbers into my quadratic formula, and I'll end up getting two values of x. So I'll end up getting x equals x1 for a b value plus whatever is under the square root divided by 2a, and I'll get another x value for b negative b minus whatever is under my square root divided by 2a. So this way I get two solutions, and if you remember, those solutions actually are representing when that quadratic equation is crossing my x-axis, right? So one solution happens there, another solution happens there, whatever it might be. Okay, so that's the quadratic formula. We also have quite a few formulas from our discrete functions unit. So we've got formulas that have to do with financial applications. That's this one, and this one. And we also have some formulas that have to do with sequences and series. So our sequences, we've got our arithmetic sequence. So that one is right here, right? The arithmetic sequence, this is just going to tell us what Tn is. So if you have an arithmetic sequence, that means you have numbers that are going up by the same difference each time, right? So in this case, we're going up by 2. So that means I have a d value of 2. So that means my d equals 2. My a value is just whatever my first term number is. So in this case, my a value is 1, and n is just however number of terms I'm counting up to. So, the nth term is going to be using this formula in order to tell you what number you're at in the sequence. We also have geometric sequences, and they're very similar, the arithmetic and the geometric one. The only difference is instead of adding or subtracting a number, like in arithmetic, we're multiplying a number. So, for example, if I was multiplying by 4 each time, my first number would be 1, second number 4, third 16, and so on, right? So in this case, I am multiplying by 4 instead of adding or subtracting. So that means my R value is 4. My A value is still the same as T1, which is 1. And N is still the same idea of whatever number of terms I'm looking for. After that, we've got series. Series are kind of like sequences, only we are summing up the sequence. So I have two formulas here for arithmetic series. These are actually both the same formula here. So this is the same formula, it's just written in a slightly different way for arithmetic series. And then I've got another one over here to help predict the sum of a geometric series. Okay, so let's talk a little bit about those financial applications. So the financial applications of discrete functions talks about three different formulas to be precise. So first formula is one that's just for basic compound interest. And we use this formula the most for savings. So this will be savings where there is no regular payment, with no payments. So that means the money just gets put in there and then it just sits there and accumulates interest. Another example of something we can use for savings is this formula right here. The main difference is that we are contributing regular payments, and that is with the value R. That's represented by the letter R in that formula. And then last but not least, we have this formula over here, and it's used mostly for loans. So in this case, we are reducing the amount that the loan is worth by making payments, also represented by the letter R. So we are paying off regularly with the letter R. So these two formulas look really similar, right? This formula looks rather similar to that one, but the main difference is you've got that negative n. So that means the number of compound periods is actually to a negative power in the one that has loans, and it's to a positive power in the one that is accumulating, right? So that's kind of the main difference that you can see visually in these two formulas. So really don't mix those two up. So one of the most confusing things I think with these two formulas is the fact that this first one that has to do with savings, sometimes you might be saving for retirement, and sometimes you might be paying off a retirement. So sometimes you might be in retirement and your money is being reduced. If you are actually using your money in retirement, you'd be using this formula. And if you are saving for retirement, you'd be using this formula. So careful about those retirement questions, because if you're saving for retirement, you need to use the formula that has to do with savings. And if you are using your retirement, you have to use the formula that is for paying, like that is for actually once you're in retirement, right? So the second formula over here, sometimes we call it the present value formula. It is used for retirements and loans and any amount of money that's being reduced over time by a regular payment R. And this other formula over here, this one is used for savings and anything that's being accumulated over time with the regular payment R. So I hope that's clarified things a little bit. I've got a few more formulas to talk about. One is, of course, the sine law formula, and the other is the cos law formula. So these are used for solving triangles, right? If you have a side A and an opposite angle A, well, we call this an opposite side angle pair, and you can use it in order to solve for another angle if you have another side as well. So if you have side B and you have side A and you have angle A, then you can find what angle B is using the sine law formula over here. If you don't have a side angle pair, so let's say you have side A, you have side B, and you know angle, excuse me, you have angle C over here. Well, we don't have an opposite side angle pair, but if you're trying to find that opposite side C, you could actually use this formula. And this formula is actually set up for a squared right now, but if I wanted to find what C was, then all I'm going to do is just rewrite the formula for C. So I do that by first focusing on C squared, and then I'm going to add up the other two sides, so a squared plus b squared in this case, minus 2ab cos of angle C. So you'll notice that all that matters is that a squared and b squared and ab, this, and this, as long as I'm not repeating C, it doesn't really matter if I put b squared first or a squared first, as long as I'm only using the other two sides and then the opposite angle in my cos part of this formula. So that's kind of a quick way that you can always rewrite the formula for any side that you might be looking for. You can also use this formula if you have all of the sides and none of the angles. So in that case, you can, let's say you're trying to find angle C, right? So same idea, I can still write out my C squared equals b squared plus a squared minus 2ba cos of C. And if I'm looking for cos of C, I just rearrange the formula, c squared minus b squared minus a squared divided by negative 2ab, and that's going to equal the cos of C. So I can, if I want to find only angle C, well then the inverse cos of all of this is equal to angle C. Right? So that's kind of a quick way of solving our triangles using the cos law. And last but not least, we've got a couple of formulas here that will help us in, I'm trying to get all of these descriptions out of the way. All right, so we've got some formulas over here, and these ones are meant to help us with our trig identities. So these are some trig identity formulas. So these are really useful if you're trying to solve a trig identity, and I do welcome you guys to go back and look at some of those some of those videos that we did on solving trig identities. The first one is sine squared plus cos squared equals 1, and the other is tan x equals sine x divided by cos x. These are both really useful identities to remember. So for example, let's say you're trying to solve cos squared x equals sine x plus 1 times sine x minus 1. Whoa, sorry, other way around. 1 plus sine x times 1 minus sine x. Let's say you're trying to solve this trig identity. Well, the sine squared x plus cos squared x equals 1 trig identity is going to become very helpful here. So in this case, I'm going to start with my right side, and I'm going to reduce 1 plus sine x times 1 minus sine x to be 1 minus sine squared x, right? Because 1 times 1 is just 1. 1 minus sine x is there. 1 times sine x is plus sine x. And then sine x times negative sine x is negative sine squared x. So these middle terms cancel out, and I'm left with 1 minus sine squared x. And well, since 1 is equal to sine squared x plus cos squared x minus sine squared x, well, I've got the sine squares that cancel out, and I'm left with just cos squared x, right? So this means my left side equals my right side. So that's kind of the general idea. And of course, if you ended up with something like another trig identity, where you had tan x cos x equals sine x, well, easiest way to solve this one is to, of course, replace your tan x. Well, I'm going to start with my left side over here. And I'm going to replace my tan x with sine x over cos x. times cos x. The cos x's cancel out, and I'm left with just a sine x, which of course equals my right side. So these are very useful trig identities that you will be provided for on your exam. So please do know how to use them. You are going to have to solve some trig identities. All right. Happy studying and good luck, everyone, on your exams.